Good morning. Today, 12.3, adding and subtracting vectors. Okay, so far when we've talked about vectors, we've only had one vector at a time. But the reason vectors can be extremely useful is, especially in like a physical standpoint, so in your physics class, if there's multiple vectors acting on one thing, it can cause maybe if you think about it as you're walking down the road, you're pushing down on the pavement. So there's that force, but then there's also gravity pushing you down, and maybe the breeze, and then maybe your friend pushes you. And all of those vectors or forces acting together cause your path to kind of be changed as you walk down the road. Okay? So when it's most useful is when there's more than one vector at the same time. Now, when we're adding up these two vectors together, we can do it one of two ways. We can either do it graphically, which here it says, when adding multiple vectors by graphing, you can place the vectors tip to tail to see the resulting vector. Okay, so what we mean by that. If we look here, we have our vector u, which has a x change of 2, a y change of 4. So right here. So this is u. We also have v, which is over 8 and down 2. Now, if we put those tip to tail, so 2, 4, you could do it either way. So this one was over 2, up 4. If I move that over here, so from this point over 2, up 4, you'll see I get right there. Or maybe you want to do instead over 8, down 2. So start at this tip, over 8, that was at 2, so over to 10, down 2. You'll see you'll get the same exact spot. And this spot right here, we get a parallelogram. That is our answer, but not just that point, it's that vector. So together they make up, let me do this in a different color so it stands out. Together they make up this vector here that I drew in red, which as you can see is to the right 10 and up 2. So graphically, if we write that, 10, 2. And that will be our answer. Now, maybe you don't have a graph, maybe you can't draw it. You also can do this numerically. When we do numerically, we add multiple vectors numerically. You must add the exponents and the y components, and then we'll get one resulting vector. So if we think about it, if we have the point 2, 4, we also have the point 8, negative 2. If we add straight down, 2 plus 8 gives us 10. 4 minus 2 or plus negative 2 gives us 2. And you can see in blue here I have the exact same answer as I got in red from doing it tip to tail graphically. So once again, that same concept can be applied when we have multiple vectors. Here we have 4 vectors, okay? So first I'm going to add them numerically. So let's write them out. If we have 1, negative 3, 3, 2, negative 5, 1, and negative 4, 4. If we just add straight down, so 1 plus 3 is 4, 4 minus 5 is negative 1, minus 4, that'll give us negative 5. Meanwhile, negative 3 plus 2 is negative 1, plus 1 goes to 0, plus 4. So negative 5, 4, that is our answer. What all of these A, B, C, and D combine to give us. Now, if you want to prove that, we can also show it graphically. So we have it doesn't matter what order we go in, A, B, C, and D. If we combine them, as long as they all are combined here, we'll do them all tip to tail. So let's start with D here. That's the left 4, up 4. Now I'm going to, just to make it easier, let's go D, C, B, A. So I'll add C on. That was left 5, up 1. So from the end, or the tail of D, if we make that, it's left 5, up 1, and that gets us to there. Okay, that would be C. Now B is, you can see, right 3, up 2, or up here, right 3, up 2. So from that point, right 1, 2, 3, up 2, right there. And that is B. And meanwhile, A is right 1, down 3. So from that point, right 1, down 1, 2, 3. And right here, our resulting vector then started at 0, 0. And we go to that spot. And as you can see, that red one, left 1, 2, 3, 4, 5, up 1, 2, 3, 4. And as you see, left, we know, -5, up 4. We get the same answer graphically or numerically. Doesn't matter which way you do it. So the only other thing we need to talk about today, well, first let's mention this paragraph. So it says, each day you're constantly interacting with vectors as you move about in the physical world. Force of gravity pulling you down, the force of your legs pushing you up, the strong breeze that you must lean into and power against, the force as your brother pushes you from behind, the force of the door that you pushed that was actually a pull. Okay, all of these vectors sum together to influence your physical location in the world. So that's kind of what I was describing. All of this is happening on your body here in the middle, and it causes you to get moved around and end up where you are. Now, the second thing we want to talk about today is vector subtraction. So vector subtraction is the addition of a vector with the negative of another vector. So if we think about it, if we have vector u minus v, it's the same as u plus negative v. And a negative vector is obtained by multiplying a given vector by -1. This reverses the direction of the vector. It's also known as negating the vector, as each component of the vector will be in the opposite of what it was. So for example here, u is 1, 4. To the right 1, up 4. V is -8, -1. So left 8, down 1. We want to do u minus v. So to negate this, multiply each of those by -1. That's going to give us the new point of 8, 1. And you'll see if we go over 8, up 1, in red here, that is not v, but -v. And now, if we are combining that with u, so u plus -v, if we just put those together, we can use tip to tail again. We can either put the -v up here or the u over here. It doesn't matter which way. U was over 1, up 4. So from that, if I go over 1, up 1, 2, 3, 4, right there. Or remember, we could have gone over 8, up 1 from the u. So from here, over 8, up 1. Doesn't matter. Either way, we're going to end up right there. So in black here, I'm going to graph that vector, which as you can see, over 9, up 5. So 9, 5. Okay. Now, if you wanted to prove that not graphically, but instead numerically, let's just add, we have 1, 4, plus, remember the opposite, so that -1 changes that to 8, 1. If we add down, 1 plus 8 is 9. 4 plus 1 gives us 5. You see, we get the same answer either way, numerically or graphically. All right, we're almost done. Let's finish it out. Let's just show that if we have u and v and we do u minus v and v minus u, we're not going to get the same thing. Okay, so let's do this numerically. So -3, 7. If we put that with -v, that'd be multiplying this by -1, which gives us -2, 11. So -2 and 11, if we add those up, our answer, -5, 18. That's a u minus v. Meanwhile, v minus u, we're going to start with the original v, so 2 and -11. We'd multiply this by -1, 3, -7. And that's going to result in 5, -18. You'll probably notice the numbers are the same, but the signs are different. So -5 and 5, 18, -18. Okay, so there we go. That's all we've got for today. Just keep in mind, if you subtract in a different order, it will change which way it's going. But hope you guys had a great day and get the Delta Math assignment done. If you have any questions, please reach out and let me know. And I'll see you guys soon. Bye.